Okay, continuing on our discussion in 3.1 about functions. One key concept moving on, if you have to go into pre-calculus or calculus, you're going to see this a lot more. It's something called the difference quotient. So difference, because we have f of x plus h minus f of x, and then quotient means a fraction. So it's a difference and a fraction all in one. And this is used for some of the key concepts in there, so you will definitely see this again if you move on. So what we're going to do is we're just going to work on actually finding the difference quotient, so when you get to pre-calculus it's familiar and you don't have to worry about that, you can actually apply it. So let's start with the function f of x is equal to x plus 2, and let's see if we can find the difference quotient for it. Now before we try to find this difference quotient, first let's figure out f of x plus h. Okay, f of x plus h. So remember what this means. This means that anywhere that there was an x, it's going to become x plus h. So x becomes x plus h. So right here, x becomes x plus h. So we'll get x plus h plus 2. Okay, so f of x is x plus 2. F of x plus h is x plus h plus 2. Okay, so putting this into our difference quotient now, we're going to have f of x plus h, that's this part right here, x plus h plus 2, minus f of x, that's what we're given right here. Okay, now when we do minus something, we've got to make sure that we subtract the whole thing. So it is super important that you put parentheses around this, because we want to subtract the whole thing, not just the first term. Alright, so these parentheses right here are super important. This will not work right if you don't do the parentheses. So we've got f of x plus h minus f of x over h. Okay, so now we're out of the function notation and now we're into things that we can work with. So the first thing that we need to do is we need to distribute this negative. So we're going to get x plus h plus 2 minus x minus 2 when we distribute that negative. Okay, so multiply through by negative 1. And that whole thing over h. Now once you distribute that negative, a bunch of stuff should cancel out. I know that this fraction looks big and ugly, but it should get down to something very simple and manageable. So we've got x minus x, those cancel out, and we've got 2 minus 2, and those will cancel out. So what are we left with? We're left with h over h. Well, h over h is just 1. So this difference quotient is equal to 1. Our answer would be 1. All right, we'll do another one of those in class, but this gives you the basic idea. All right, the next function concept that we're going to talk about is the idea of domain. So the book definition is the largest set of values for which f of x is a real number. As far as book definitions go, this one's not a bad one. They're saying you want to find all the values that make your function or your y value a real number. So basically you're looking for all of the allowed values of x. If there's a value of x that would give you something that's undefined or a complex or imaginary number, those aren't going to be in the domain. Alright, so let's look at a couple of examples here. Let's say that f of x is x squared plus 4. And we want to know what is the domain. Well, the domain is saying what are the allowed values of x. Sometimes it's easier to try to figure out what isn't allowed. So let's go through all the things that we could possibly plug into x. So can we plug positive numbers in for x? Can we take a positive number, square it, and add 4? Yes, of course we can. Can we plug 0 in? 0 squared plus 4? Yep, that's fine. Can we plug in negative numbers? Negative numbers squared plus 4? We can do that too. We can plug in fractions, decimals, we can plug in anything we want, and we're going to get a y value that's a real number. So the domain for this one is going to be all reals. Okay, or an interval notation, which we'll talk about in later sections, negative infinity to positive infinity. Any value of x is going to work in there. All right, let's look at this one. F of x is equal to 1 over x plus 2. What kind of x values can we plug in here? Well, there are a lot of x values that work, but what doesn't work? Where do we have a problem with a fraction? Well, in general, fractions are defined when it's something over 0. So we have to worry about zeros in the denominator. Now for the ones that we're going to look at first here, you should be able to look at it and figure this out. When is this denominator 0? When am I going to have a problem? Well, if x is -2, I get -2 plus 2, I'm going to get 0 in the denominator. So -2 is going to be a problem. Anything else that we plug in, we might end up with a fraction, whole number, negative number, doesn't matter, but any other number is okay. -2 is the only one that gives us a problem. So we say that the domain is x not equal to -2, meaning all reals except -2, or we can write that, all reals except -2, okay? Or the way that the book writes it, they write it in set notation, and this curly bracket says the set of all x such that x is not equal to -2. All right, you don't have to recreate the set notation. Just make sure that you can match the condition part right here. X is not equal to -2. That's the part that we need. And you need to make sure that you say that it's not -2. If you tell me that it is -2, then that's the exact opposite of what we want, and that answer is not going to be right. So you have to make sure you say everything except -2.